So Pygame, like I said, is a library that is built for creating games. It's written in C++ and in assembly, which are very, very fast, which means that the use of this huge library won't slow your games down at all, which is really nice. Um, and it's very well written, and it's very, very big in terms of what you can do with it. This is another one of those libraries like TK Interface that I could teach an entire class on easily. Unfortunately, nobody wants to pay me to do that yet, so I'm just waiting. Um, what does Pygame do for us exactly? The first thing that it does is that it makes the structure and objects of a game that you would typically find in a game very easy to use. Two examples of these are sprites. Okay, so a sprite in a game, I'm not talking about the soft drink or a little fairy. A sprite in a game is basically any object that moves or can be interacted with or does something. So sprites, if you think of like Super Mario Brothers, right? Super Mario Brothers, Mario is a sprite. All the little bad guys are sprites, little mushrooms, and the mushroom and the blocks that you hit when you're Mario, those are all sprites. Okay, there are things that can be interacted with. The background of the game is not a sprite. That's a background image. Okay, so that's a sprite is something that is kind of in the foreground of the game, usually can be interacted with, usually moves or does something. Collisions are something that are really, really fairly complicated to program from scratch. Because a collision means being able to detect whether a sprite is touching another sprite and in what way and how they're touching and that kind of thing. Collisions are complicated, right? Because if you think back to the Super Mario Brothers example, right? If Mario runs into a bad guy sideways, Mario gets hurt. If Mario jumps on top of the bad guy, then the bad guy gets hurt. So understanding those collisions, how they're happening, when they happen, being able to determine if Mario is hitting a block or standing on top of it or jumping on a turtle or whatever, those are all important to be able to detect because that's the nature of the game, is those interactions between those sprites. Collisions happen throughout all kinds of different games. And the old way to detect is to take the coordinates and the size of every sprite and do some kind of math to see if those two sprites are touching or occupying the same space. Now I can say with one command, is Mario touching the turtle? That's it. That's the whole thing. And it says yes or no. So collisions, super easy with Pygame. Updating the screen. Okay, updating the screen, we take it for granted. But if you think about it, there are no moving pictures. Okay, when you look at a screen, at a video game, and you see all this stuff happening, what you need to understand is that those things aren't moving on the screen. What we're seeing is several hundred frames per second or several dozens of frames per second, sometimes 100 frames per second if you're like a high-level elite gamer and you've got a great system and a great monitor and all that stuff, you might get up to 120 frames per second, somewhere in that neighborhood. Some people push 160. I think that's probably unnecessary, but you know, maybe my eyes are just untrained. I don't know, right? So, but the screen is updating, putting a new picture up, and in each picture, those items on the screen are moving ever so slightly. And by showing those pictures in rapid succession, what we see is animation and movement. Those screen updates are hard to program when you have dozens of different sprites on the screen all doing different things. It's not easy to manage those screen updates. Pygame takes a lot of the work out of that for you. Interacting with a mouse or keyboard or game controllers, Pygame takes care of it for you. Makes it really, really simple to do that stuff. So it really lets you focus more on what's the game I want to make? How should it work? It takes care of sounds, writing, even drawing on the screen. You can do all that stuff with Pygame. What we need to cover before we start looking at code is some basic concepts, because it'll help the code make more sense to you when we look at it. So this is the game we'll be playing around with today. What's that? You basically have little missiles that fly from the right-hand side of the screen, and you're trying to dodge them with your airplane. No, but you can. I mean, it could be your game, whatever you want to do, right? So we've got a score. Every time a missile crosses the screen and doesn't hit you, you get another point. Okay? So really, really simple. When the missile hits you, the game is over. That's it. So on this, and I made this purposefully simple, this is based on some code from a website called Real Python, where they have a tutorial on Pygame. I took their code and actually simplified it because I want to make it really, really simple to track what's going on here. We've got missiles, we've got airplane. Those are the sprites on the screen. And the score is not a sprite, but it is drawn on the screen dynamically. So each time you create a new screen, you draw the score on it. So the sprite, each sprite has two parts to it. The surface of the sprite, and it's pretty easy to remember which is which. The surface of the sprite is the part you see. It's the graphics, it's the image, it's what it looks like. So the surface of this sprite is this airplane. And the interesting thing about this airplane, if I open this up, where are my images? Okay, this is the actual sprite from the game. Okay, it's enlarged quite a bit. So the sprite from the game is an airplane on a white background. We actually use an index, kind of like we do with a GIF compression transparency, to make that background transparent so you don't have a square flying around the screen, because that wouldn't be a very fun game. So instead of a square with an airplane in it, we see just the airplane. So the surface of this is that image. The rectangle of the sprite is the space that it occupies and also where it's positioned on the screen. So there's an invisible rectangle that's the same size as the image that controls the collisions. It controls where this is on the screen, and it keeps track of the interactions of that object. Okay, so that's how we position it. How it looks is the surface. So if I wanted to animate this, so it has a little fire coming out the back of it, or maybe when the missile hits it, it explodes. Those are things that would be done by modifying the surface aspect of this. If I wanted to change the rectangle so that a missile would explode if it gets too close to the airplane, then I would make the rectangle bigger, because often that's referred to in game creation as the hitbox, right? So the hitbox would be larger, and then it would interact differently.
How advanced can public games be made? Like,
unbelievably advanced.
really?
I'll show you some examples later. Yeah, you can make you'll be your mind will be blown with some of the stuff you can make. It seems like, oh, that's cute. I don't really want to make that game, but that's cute. No, you can. I mean, it goes really deep. So another thing that you need to understand about Pygame and how it works is that it works like a flip book. Anybody make one of these before? Where you go and you see a little animation? That's a great metaphor for how Pygame works, in that each time there's a screen, you have to draw it first, and then you flip it. So you're seeing a screen right now. At the same time you're seeing a screen, a new one is being created in memory that you can't see. Once that screen is drawn, then you flip it. So blit is how we draw things on the screen in memory. So screen.blit, you'll notice the surface and the location. The location can also be just the rectangle, because the rectangle passes the location. So you can do surface and rectangle of the sprite, and that's it. That's how you draw the sprite on the screen somewhere. Once you've drawn everything, you hit screen flip, and it flips. So every time that game does its cycle, we're drawing and we're flipping. So it's like a flip book, except you're dynamically drawing the next page as it goes, because you can't draw the whole flip book ahead of time, because that's just a predetermined animation. In a game, everything's interacting with each other. So you have to draw as you go. But blit and flip, so you'll see those in the code. That's what those do. Everything in a game is controlled by what's called the game loop. The game loop happens once per screen update. So in those elite gaming systems, if you're playing a first-person shooter and you have 100 people on screen all interacting with each other, and you're running around shooting and things are exploding, all of that is updated 120 times per second. So this cycle repeats that quickly. That's what those machines are handling, which is pretty impressive. And in those games, it's network communication and all kinds of other stuff too. So it's pretty cool. So the way it generally works is on the game loop, you get user input, you update the sprites, the location, the look, the animation, whatever. You draw the background. So the sprites are updated. Then we draw stuff. We draw the background. We blit the sprites and objects on top of the background. It's just like painting. Okay, so if I'm going to do a little painting, I'm going to paint the background, and then I'm going to paint the trees on that, and then I'm going to paint, if I'm Bob Ross, I'm going to put some happy little birds, right? So that's how this works. Same way. You draw the background, you draw the sprite. If I want a sprite to be on top of another sprite visually, I draw the background, then I draw this sprite, and I draw another sprite, and it just layers them on in the order they're put on the screen. And that keeps it really simple. Next, we do a collision check to see are sprites touching each other. Okay, if I have a shooting game, the players are sprites, but so are the bullets. So I want to see is this bullet touching the player, and what happens if it does. So I deal with that. Finally, once I've dealt with all those things, I flip the display. Then I use a clock to control the speed of the game. It's interesting, but what the clock does is it actually slows it down. If I let a game run at the speed of my processor, at just whatever speed it will go, the game will be over before I even know it, because it will have played through before I can even move my character. As a human, my ability to respond is not as fast as the computer's ability to draw 20,000 frames. So the clock actually slows it down so that it's playable. But in Pygame, that's one of the ways that we can control the difficulty of the game, is by speeding up or slowing down the clock, which makes the game run faster or slower. So there's a lot of different variables you can play with to make the game interesting or difficult or less difficult, depending on the game. And then, of course, what we check for in the last part of the loop is the game over? If the game is not over, we just keep looping. So it's basically a while true that goes until the game ends, right?